Welcome back, everybody. We are working on the snake temperature control project again today, and we made a bunch of improvements. We upgraded the hardware, we've upgraded the software, and so let's get into it. So this is the old setup. This is the relays on the bottom left of the corner of the picture, the Arduino Uno on the top connected to the breadboard, and then the temperature sensor goes off of the screen that you can't see here. You can see those relays have the tops cut off. That was the only way I could get those to function, as I talked about in my previous video, which if you haven't watched the previous video, go back, watch this one, then come to this one so that you are caught up. But I ordered some new relays. So this is an 8-panel relay. They're actually really close to each other, which makes them kind of difficult to use. So I had to, you'll see in just a minute, I had to use one and then skip one and then use the next one, skip one, use the next one. But much nicer, much cleaner setup, much newer relays. And this is the RTC, the real-time clock module that I'm using to keep track of the clock. Because one thing that we did upgrade in this video is we gave it daytime and nighttime control, so the visible light heat lamp is not on at night, and only the infrared light is on at night, and then during the day, or when it becomes 7 a.m. local time, it switches over to the daylight lamp. And we'll go through that code here in just a minute. So this is a picture of the entire setup, really messy right now. The next video, we're going to be building, 3D printing a case for all of this and cleaning up the wiring and making it look all nice. But this is what it currently looks like. Doesn't sit on top of the metal cage like that, as that would be an electrocution hazard. But you can see the new relays, the breadboard, the clock in the middle, and the Arduino Uno, of course. So jumping into the code here, we've got just our libraries up top. We did have to include a couple new libraries for some communication protocol because the RTC required it. And then this is pretty much unchanged. So we go to the setup. This is just the setup for the clock, and we use serial flusher because we want to make sure that we know that the RTC has malfunctioned at the beginning of the boot up process, so that if we need to change something, we can change something right out the gate. Because as the program, you'll see in the program as we go on, there is no control, no contingency plan for if the clock goes out, which is something that we're going to need to add in another iteration of this setup. But right now we don't have it, so we didn't want the program to continue past this point if the clock has an issue. And then if the clock, this is just standard programming. If your clock loses power, you need to reset the date and time. They come with a little battery on them to keep the time if it doesn't have any power, which is pretty nice. And then this is just a startup. So again, we want to turn all of the relays on, turn all the relays off, just to make sure everything is functioning as it's supposed to. And then we get into the loop. So this is just some programming to get the time printed from the clock. And then this chunk of program just is in case the temperature fails. So this is going to get the temperature, and we're going to put that into this float variable, and then we're going to print out the current temperature. Then we need to determine what is daytime and what is nighttime. So if it is it is daytime if the current hour is greater than 7 or less than 21, which is 9 p.m. So if daytime is true, then we will do this chunk of code, and if it's not true, we'll do the next chunk, which is almost identical except for which lamps have priority to turn on. So if it is daytime, we're going to read the temperature again. Then if we have a temperature failure, we're going to go to this safety mode, which is we have just one infrared light on. One thing that did change from the previous code is the relays high is now off and low is on. I had to go through and switch all of that for all the relays, because these relays low is on and high is off, which is standard for relays. It was weird that my other ones were reversed. So this is how you normally see relays. But if we get a temperature failure here, we're going to go to this failure safety mode where we just keep one heating lamp on. Then we're going to print in the serial monitor that we are on daytime control, and print the hour and that we are doing daytime heating. That's just for diagnostic to make sure that the switching is happening One thing I do want to add is a LCD screen so that you can see what the program is doing and what the current temperature is, but that will be for a future video. Then here's just the control logic. We also switched all of these out from ifs to else ifs because I didn't realize, but this program would only run appropriately if the temperature was starting below 80. If you look at the last video, none of the other ifs would be triggered. So I had to switch these from ifs to else ifs, which is luckily that we figured that out. So if the temperature, the first one, if the temperature is above 88, turn everything off. It's just going to be too hot in there. And then this is by and large the same as the previous video, so I kind of just gloss over this. If we're less than 75, turn everything on. If we're less than 80, turn 1 on. Check the temperature. We have that temperature failure here again. And then else, which is just going to take control of the, if we're between 80 and 88, just kind of simplified the code there. Then we're going to turn one of the lights on and one additional light. So because it's during the day, we're going to have the visible infrared heater on, and then we're going to turn on one additional heater. And if we're in the range, we're just going to have that one visible light on. Then we needed a way to break out of this because if it was turned on during the day, it had no way to check the time to see if it had become night now. So if the current hour is greater than or equal to 21 or less than or equal to 7, then we need to break out of this loop. Now this does not push it into the nighttime control. This will just break this daytime loop, and then it will come back here to check this bool value, the Boolean value. So if we break out of this loop for some condition that we're not accounting for under this if statement, then it could just come back into the daytime loop. But if it is nighttime and we've broken out of that loop, then we'll come down here to the nighttime control, which is exactly the same as the daytime control, except as you can see, the visible relay is off, visible relay right high, and we're just running the two infrared relays to heat it up if we get below 80. And then of course if we get below 75, that's just too cold. We are still turning all of them on. Better to bother the snake with some visible light than it is to let them freeze to death. So and then the same thing here, we're going to break out of the loop if given the time of day right here. If the current hour is greater than 7 or less than 21, then we're going to break out of the loop and let it decide which, if it needs to be daytime control or nighttime control. The nice thing about this is we could let the temperatures drop down a little bit lower overnight. That's something that we haven't set for yet. And then if we do break out one of these loops, we're going to delay 500, just give everything a little bit of time to settle. The relay switching is a lot faster and a lot more responsive with these new relays, and so I was able to take out some of the delays when we're turning all of the relays on because we don't have any relay switching problems anymore, which is really nice. And here we have a video of testing, switching from nighttime to control to daytime control. And this is not the actual time. We use 7 a.m. to 9 p.m. for the daytime control, but for testing, we're going to have it switch at noon. And so as you can see, the serial monitors counting down the time, you can see the seconds. And right as soon as we get to 12, it goes ahead and turns off that infrared light and turns on the visible heat lamp because it's now under the daytime control. And then the opposite would be true when it gets to 2100 hours or 9 p.m. It would turn off this visible light and switch on the infrared light. So this is a little bit of an overview of the wiring diagram. It's not perfect. We had to make some artistic liberties on here. We'll go over those, but it kind of gives you a general sense of where everything is wired to. So this LED is where we'll start because it's not an LED. This is our clock module. I'm using Tinkercad here, as you can see, and they didn't have an RTC module. So this is just an LED, but it had the same number of pins, so it worked well. The next concession we had to make was these little photo cells. They are the power plug. So this is where we would plug into the AC power. Again, Tinkercad just did not have a model for that, so this is what we had to use. Aside from that, it worked pretty well. These are relays, but this, in the real project, this is all on one board. We showed that picture of it earlier, and this is our temperature probe. So let's start over here with the Arduino. The Arduino Uno is actually powered by a plug that comes in right here, and that's how we power it normally. And then this is, of course, the connection for the serial monitor if we're doing that. But when it's normally just running, we just have the power coming in through here. Then the temperature probe that is inside of the tank, we just have positive and our ground coming over here to our positive and our ground bus. coming out of the 5 volt, and so we got that powered. And then the output comes to digital pin 5. And then the next digital pins that we have are the 3 that control the relays for the heat lamps, and they just come down to the breadboard and plug into any arbitrary slot here. And then that signal gets transferred over to this cable, which gets carried down to the 3 relays that they use. Those are plugged into, as you saw in the program, D2, 3, and 4. Then we have the real-time clock that uses A4 and A5 for its communication, and then just power plugged into the power bus. And then we've got a power bus that runs into the back of all of the relays. And then we've got our mains power that come in for the heating lamps, and we just cut the ground wire and hook it up to the relays for each of them, and then run them down to the lamps. So when the clock sets the time on the Arduino, that tells it if we're using daytime or nighttime control, then the Arduino checks the temperature, and then it sends a signal down the signal wires to activate whatever relays it needs to get to the appropriate temperature in the cage, and our heat lamps turn on. And of course, one of these is visible, and the other 2 are just infrared. So that's just a quick little down and dirty overview of the wiring schematic. So that is the upgrades for the tank right now. We added the daytime, nighttime control. We upgraded the relays. We added the clock, and everything is going great with this project. So next week we're going to release another video, which will be the 3D printing of the case for the control box, and we're also going to add in some humidity, so we can do some humidity monitoring also. So if you have any questions or you want a copy of the code, post down below, leave a comment, like, subscribe, all the YouTube things, and we'll see you in the next one.